This is the Biuret test for peptide bonds. It tests for peptide bonds, and as such, we also say that it is a acceptable test for proteins because peptide bonds are bonds formed between amino acids when they're making proteins. For this test, we have a couple different things that we're going to be testing. I have some oil, some soy milk, almond milk, normal milk, some yogurt, and right here I have some bread. I put the bread in some water. I'm just going to try to break it up some so that we can get some molecules that we can that are broken apart and free that we can use and that can the Biuret reagent. Here's my Biuret solution. As you can see, it's a little bit of a bluish, maybe a slightly purple tinge to it. Just going to pour a little bit into a beaker. Should be enough. I only need 1 milliliters for each of my samples. Now, super complex procedures right here. I have 2 milliliters of each of my samples, and I'm going to add 1 milliliter of Biuret reagent to each sample. Now, I'm looking for some sort of color change. The reagent is a blue color. So the reagent's a blue color, and we're looking for some sort of change to a purple color. The purple will indicate the presence of peptide bonds, which will indicate the presence of proteins. And just hypothesizing, I would expect to see some sort of protein in my soy milk, my almond milk, my normal milk, and my yogurt. I would not expect to see proteins in oil because that's primarily going to be fatty acids or lipids, which are lipids. And I really wouldn't expect to see it in my bread. There could be some proteins in bread, but usually when you break bread or bake bread, you break it hot enough to destroy those proteins. I would expect to see it in all my different milks because one of the primary things in milk is protein. That's why you'll feed them to babies to get lots of protein into them and lots of calcium and lots of other nutrients, including lipids. But proteins is one of the things you expect. So you'll put the Biuret reagent in there and you'll try to mix it up some. You notice right away that the oil isn't even mixing with the Biuret reagent. Mix up my soy milk, and we have another density issue here where it's not mixing very well, but you can definitely see a color change. It's a purple color. Mix up the almond milk, and again, we have that nice color change. Standard milk. Yogurt. It's hard to mix with the yogurt, but you can definitely tell that there's a color change going on right there. It's got bright purple. And there's a little bit of purple here with the bread. It's hard to see, but there's definitely purple. So there's some peptide bonds, some protein in there. So the way you would indicate this on your handout is you would say that the color you have here is blue. You don't say no change or no effect. This is a big deal. I was reading through some AICE materials this last weekend, and they said you don't put no change, no effect. You put the color it is, and what does that color mean? So blue means no peptide bonds. I don't say no change. I say blue. That means no peptide bonds. Purple, 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 peptide bonds. So I put proteins in 4 of my samples. And then my last, 4 of them, 5 of them, 5 of my samples, including bread. And then my last one does not have proteins in them. And that's how you do the Biuret test. Like I said, super complex.